Okay, so the first part that you see on the first page is steps of graphing rational functions. So this is what we've been doing all the time. This is very clearly organized the way that you can figure out all the steps to graph rational functions. So if you remind yourself of the step-by-step approach very well, and I think it's gonna help us to reason backwards. So simply all the examples that you see on this file is about given graph of the rational functions that you will create the function equations based on the key features that you can observe from the given graphs. Okay, so then what we were doing step by step when we're supposed to graph rational functions, first we always factor numerator and denominators separately so that we can simplify further by canceling the same factor top and bottom. Then that factor that we are supposed to cancel as a common factor from numerator and denominator will serve as a hole on the graph. And this hole is a kind of break that is caused by the canceling common factor top and bottom. Then this one is caused by the discontinuity that we can observe. The way that you can find the order pair of the hole is placed, you use the cancelled common factor to figure out the x-coordinate of the ordered pair. Then with the x-coordinate, you can substitute the x-coordinate back in the simplified equation so that you can calculate the output, which is y-coordinate of the hole later, right? So that was the first part. But not always you expect your rational function to have the hole. Sometimes you just don't get to have any common factor canceled and then there's no hole at all. And the next step is once you have simplified, entirely factored and simplified rational function equations, then from the denominator you can find vertical asymptote from the denominator. Whatever the surviving factors on the denominator, set it up with a 0 and you will solve it for x and then it will give you the information of the vertical asymptote. You can have one asymptote or you can have multiple vertical asymptotes. It's case by case. Then if you are done with the vertical asymptote and you can observe how the degrees of each side, degree of the numerator, degree of the denominator, you can determine if you have horizontal asymptote or slant asymptote. If you have two cases, which the degree of denominator is exactly same with the degree of numerator, then you will have horizontal asymptote. The position will be y equals whatever the ratio from the leading coefficient from numerator over the leading coefficient from denominator. So it's simply leading coefficient from top over leading coefficient at the bottom will get you where your horizontal asymptote is placed. Okay, then another case is if you have degree of denominator is greater than degree of numerator. So I usually say it's bottom heavy. In that case, no matter what, you will have horizontal asymptote at 0, which is the x-axis. So then besides these two cases, there is another cases. Degree of numerator is 1 degree larger then the degree of denominator. So then this is the case that I usually refer back to be top heavy. Then you will actually perform the long division, the 1 degree larger top divided by the 1 degree less bottom, so that you can come up with the actual linear equation that indicates the slant asymptote. Slant asymptote directly will be the linear function which takes straight slant line based on this. So quotient of the long division will serve this part, mx plus b, and then you make it equal to y, then this one becomes the slant asymptote directly. So now, all this summarization step by step is essence of the quiz that you had this week. So that means you didn't really master the steps how you could verify all of them to grab it. So I just checked the quiz result that a lot of you guys just forgot to factor numerator and denominators to see if there is a common factor from top and bottom to cancel in order to have the points of discontinuity or not. That was about the number 1 quiz. So maybe that's why you guys just didn't do well on there. But pretty much the quiz was fair, I think. No? Well, okay. I'm just gonna move on. So this was pretty much the step 1 through 4 that what we need to graph rational functions. Okay, so then with that knowledge, and we will move to first example. Okay, let me zoom a little bit up. Okay, as you can see, there is a given graph, and then we will fill out okay, give me a second. Oh. Sorry. I guess it was really windy and my window was going crazy. Okay, so now this is the graph that we're given. And we will find all the key features one by completing these tables. Then with these key features that we will observe from the graph, then step by step we will go through the reasoning, how we can come up with the equation backwards. Okay, so now holes, vertical asymptote and horizontal asymptote and slant asymptote and intersect. Then let's observe the given graph here. You will see better picture when you open the PDF file because it's color coded, but this one I only have the black and white printer, and then this is all I have, but I will explain what's in there. Okay, holes. Apparently I don't have any holes. Any hole will be notated with open circle, but I do see there's emphasized coordinates, but these are only emphasized with the closed dot, and then they are continuous. They are x-intercept and y-intercept. So apparently I don't have any holes, so I would just say none here. Then vertical asymptote, I do have 2 vertical asymptote passing through where x is 1, 2, 3 to the left, so it's -3. And another vertical asymptote is 1, 2 to the right, and then it's 2. So then I can write, I have x equals to -3, and I have x equals to +2, 2 vertical asymptotes there. Then do I have horizontal asymptote? Yes, I do. There's dashed line pass through y equals positive 1. So now I can write y equals positive 1 there. Then do I have slant asymptote? No, I have horizontal asymptote. So for slant asymptote, it's none. Where do I have my x-intercept? -4 and positive 3. So coordinate-wise, I can have two x-intercepts at -4, 0 and 3, 0. Then do I have y-intercept? Yes. At 0, 2. Alright guys. So far so good? Okay, everybody's following until here? Good. Oh, holes? I don't have any holes. How can we tell? Because it's gonna be notated as open circle. If I just see you another, so this one is number 3, then now this is open circle. So this is obviously hole. I will go over this later. Yeah. But this one is just emphasized to be there, indicates it's just x-axis. But I can tell it's not a hole because it's still closed circle. A hole is only the open circle, right? So now it's obvious, okay? Okay, so then, now, as we already remind ourselves, the connection between parts from the equation and parts from the graph, that now I can analyze this obtained key features, then I can write the equation in a certain form. One thing that you have to remember is rational function has a fractional form. It does have numerator on top. It does have denominator on the bottom. But we always have factored forms. So that being said, between this vinculum, this thin line, I always have multiple factors on the bottom. I always have multiple factors on top. Case by case, I could have just only one factor or many factors. I could have two factors. Sometimes I don't even have any factors on the bottom, but I can just tell this, right? Then another thing that plays really important role is the coefficient, the leading coefficient. We usually use the unknown A to be leading coefficient, and then we just put it there and figure it out. But in this case, we already observed it could have leading coefficient on top, it could have leading coefficient on the bottom. But since this one comes as fractional form, eventually we will have the simplified ratio between leading coefficient from top and bottom. So eventually I can get the ratio only on top. So to simplify the format that we're using, so we're gonna put that unknown leading coefficient A in front of all the factors on the top only. So this could be just typical form template for us to use to figure out the equations of rational functions from now on. So then let's figure out some factors that we can start with. Do I have any holes? No, not this case. So then now I can move on to vertical asymptote. As we mentioned before, vertical asymptotes are from the denominators of the rational function. So now let's build the denominators, the factors on the bottom. So then, how many vertical asymptotes do I have? 2. Where are they? -3 and 2. So the way that we figured this out earlier, graphing it, is from factors. So I know for sure I will have at least 2 factors. So to have vertical asymptote at -3, what was the original factor that I was supposed to have inside of the parenthesis? It's x plus 3. so that we could have just set this up with 0 and solve it. I could have had x minus 3, right? So then from this vertical asymptote that I could have had x minus 2 to be the second factor of my denominator. So these two are from here, and then I input those. Okay, so then that was bare minimum for me to have it there. Then now, let's move on to the horizontal asymptote. The horizontal asymptote that I have here is y equals 1. And we already mentioned there's two cases. Either y equals 0, which is x-axis, or I could have y equals to a certain value here. What I have here is 1, down here is 1. So I'm not going to go with this case, so I have to have this case. This case just forces to analyze this case. The degree on top should be the same with the highest degree on the bottom. And since I have y equals 1 here, the leading coefficient from top over leading coefficient bottom are the same, so that it can have whatever the leading coefficient on top and the bottom makes 1 at the end. 1 at the end. So then, let's figure this out. First, the degree on numerator should be 2. Why? Because look, this x will multiply this x would have made x squared on the bottom. So then highest degree that it could go with the x is 2. Then it has to match on top. So I supposed to have the highest degree x squared term there. Then I can write typical quadratic equation with ax squared plus bx plus c, because we verified the degree that it could go the highest on top is 2. Then we already observed the ratio from leading coefficient top over leading coefficient bottom should make 1. Then if I don't see any particular leading coefficient at the bottom, then I can make the leading coefficient of numerator 1, so that it's 1 over 1, making 1 there. So the left out unknown b and c for us to figure out to complete this equation. Then what could be the method for us to figure out this unknown b and unknown c? Of course, we can use coordinates from x and y intercept. When you plug or substitute x values, it's supposed to be equal to y values. Then either of these coordinates will help us to find the unknown here, right? So then horizontal asymptote determined the numerator based on how we build the denominator first. Yeah, okay, then now with this x-intercept, now I will figure either b or c. Then let's do y-intercept first. So then y-intercept is when you substitute 0 wherever you see x, then it's gonna be equal to 2. So then first, f of 0 will make this current expression. If 0 goes in here, it's 0 squared is 0. And 0 goes in here, it's b times 0. Whatever the b, x is 0, so it's gonna make another 0. Then c will be copied down, no all over. Now I'm still plugging 0 here and there. 0 plus 3, which is 3. And then they are multiplying, so it's times. 0 minus 2 is negative 2. So it's negative 2. Then equal to what value? It's right here, 2. So it's 2. Then 0 plus 0 plus c is a c. Over 3 times negative 2 is negative 6. Then equal to 2 is 2 over 1. Then what should be the value of c? You can do cross multiply. C times 1 is c. And negative 6 times 2 is negative 12. Then if I know c is supposed to be negative 12, you can rewrite this expression with c value that we just found. So it's going to be x squared plus, still we don't know b, x. Instead of c, I can write 12 there. Then x plus 3 and x minus 2. Then now I can use additional information from x-intercept. It doesn't matter which one you pick, but let's go with 3, 0. When x becomes 3, it's gonna be equal to 0. So then now I'm plugging input 3. Then it's gonna follow this. 3 squared, 9, plus 3 times b is 3b. Then it copied negative 12 over. Now I have 3 goes in here. 3 plus 3 is 6 times 3 minus 2 is 1. And then it was supposed to be what? 0. So then it's 0. So then let's simplify each side. 9 plus 3b minus 12. So the like terms is 9 and negative 12. So it's going to make negative 3 plus 3b over 6 times 1, 6 is 0. Then it's 0 over 1. Cross multiply again. Then negative 3 plus 3b times 1 is as is. And 6 times 0, it's going to make the other side 0. So then if I add 3 to both sides and 3b is 3, divide both sides by 3 and b is 1. Then we're done because b turned out to be 1. Then the final answer that we are writing up here will be x squared. Because b turned out to be 1, I can just make x. Or you can just write explicitly 1x minus 12. And then it was over 2 factors that we found is x plus 3, x minus 2. So it's going to be x plus 3 and x minus 2. Then this is totally fine for me to see as final answer. But it's not really conventional. So if you care, it's totally fine. From this step, you can expand the denominator so that you can have expanded form top and bottom. Or you can even go ahead and factor the top. Notice this is factored form, and then you can make it factored entirely so that you can just have all this form. So it doesn't matter. Because this proves that you know everything, how to analyze it, convert it into the equation. So I would not care what form that you take. It's totally fine. You have expanded form on top and factored form on the bottom, or vice versa, or you match the form and then it's totally fine. Okay, so far, any question? Are you sure? Ask me now. Don't say the next week quiz is like so hard. Okay, then.
I have a question.
Yes, go ahead.
When you solve for C,
yes.
Why did you put 0 for f of 0?
Oh, I'm using the coordinate of the y-intercept. Y-intercept is at what? 0, 2. So that means when x is 0, the output y is 2. So then the input x is 0. So input x is 0. Then it will turn all the x's into 0. Then it's going to make output equal to 2 there. Then same manner, when I was using x-intercept 3, 0, it works the same. What I'm inputting is what? 3, which is x coordinate, and then I make it equal to output 0, the other side of equal sign. But all the x's turn to 3. So x squared is 3 squared is 9. And then b times 3 is 3b. And then 3 plus 3 is 6 times 3 minus 2 is 1. Cool? Cool. Okay. And let's move to the next one then. Okay. So number 2. Okay, this is the graph that we have for number 2. Now, I can recognize my vertical asymptote here, -2 and +5. And then I recognize my horizontal asymptote at y equals 1, so that I can verify my curves are perfectly behaving as it was bounded by vertical asymptote, horizontal asymptote, and vertical asymptote. But one thing that's really weird is that even though this is horizontal asymptote, my graph is still passing through the asymptote. So this might cause some question. Wait, we always talked about asymptote being where your graph cannot become or across. But how come this one is like actually a crossing here? So only exception that you see is a type of rational equation will make their graph pass through their horizontal asymptote sometimes. So only this exception with this type of rational function that allows the part of the graph pass through the horizontal asymptote. But this is fine for this type of rational function. But all other functions, for example, logarithmic functions or exponential functions, will not have this type of phenomena happening. Okay, so then recognize this one is one of the exceptions that rational function would have around the horizontal asymptote, and then we will apply exactly same steps that we had in number 1 in order to figure out the equation for this number 2. Okay, so then now I have 3 emphasized closed dots. I don't have any open circle anywhere in my curves. So now this is still the same. No observed hole, no discontinuity. But I do have vertical asymptote at -2 and 5. So I will write it x equals -2 and x equals +5. I do notice there's 2 vertical asymptote. Horizontal asymptote is where, yeah, it's the same, where y equals 1. Then you remember what we analyzed based on horizontal asymptote 1 in previous one, and it's going to be applied the same. I don't have any slant asymptote, none. But I do have x-intercept and y-intercept. 2 x-intercept at -5 and 4. So the coordinates will be -5, 0, 4, 0. Y-intercept, I do see y-intercept there. It's 0, 2. So these coordinates will be substituted properly at the end for us to figure out unknown coefficient of any part of the equation later. Okay, so then let's start building our denominator first. Skip whole part, I don't have anything. Then vertical asymptote from denominators again. So now I will make 2 factors on the denominators. So first, I will have two parentheses on the denominator. From where the vertical asymptote negative 2, it's going to be x plus 2. From x is positive 5, and I was supposed to have x minus 5 on the bottom there. Now, horizontal asymptote is also y equals 1. Then, this tells you that same degree, top and bottom, So, and then the leading coefficient from top is 1 over leading coefficient from the bottom is also 1. So that you can have 1 over 1 eventually makes 1. So then let's observe what degree would your denominator have. So then it's x and x, multiply them, it would have x squared. So then I don't have any specific leading coefficient there, it's 1. So then I can match this leading term on top as just 1x squared. Then it has to have the typical form of quadratic trinomial expressions. I can go by x squared and then bx plus c, so that we can find each part correctly later. Then what did we do earlier? Yes.
What is the function in the middle called?
Function in the middle? Oh, these are just one function graph. It's not separate function.
The numerator is always like quadratic formula?
Not always, but this case it has to be quadratic. If this denominator was degree of 3, then you could have leading term x to the power of 3, which is cubed.
It's always just whatever the denominator is?
Yeah, because I do have the case horizontal asymptote is y equals a certain value. So for example, if I had y equals 5, right? So then, first of all, since I don't have any slant asymptote, it's not gonna be top heavy, right? But I don't have y equals 0 as horizontal, so I'm not gonna have bottom heavy. Only possible way for us to have horizontal asymptote with x equals a certain value is same degree. So then I will look at what possible highest degree from the bottom. So in this case, it's 2. And then I have to make the highest degree that it can go with the numerator is 2. If I have one more factor and then it was supposed to be x cubed, then I will make the leading term on top is x cubed. Then probably you might have to have ax cubed plus bx squared plus cx plus d form down here so that you can figure out all the possible, the leftover later, right? Then if this one was y equals 5, then probably the denominators set with the leading coefficient 1, then the highest degree term x cubed would have what? 5. Then the other terms will be figured out by substituting some given coordinate. Does that make sense?
So the leading coefficient is always a horizontal asymptote?
Yeah, because look, okay, let's go back to here. Horizontal asymptote is determined by two cases. Whether the degree of denominator is the same, degree of numerator is with the degree of numerator, then you will figure out y equals a certain ratio, leading coefficient on top over leading coefficient on bottom. Otherwise, if you have higher degree on the denominator, doesn't matter what you have on top and bottom, it's gonna be just y equals 0. It's always the x-axis plays as a horizontal asymptote. So that either way, we cannot go with case because y is 1. Then we assume degree top and bottom is the same, right? And then value the y is equal to is 1, so it has to be same leading coefficient as well, top and bottom. That's what we have the conclusion. Yes. Yeah. Okay. So then, now, okay, so let's erase this because that was just random example that I added. Erase it, erase it. Okay, erase this too. Okay, then we can use this coordinate to input in order to find either B or C. So then the first substitution from y-intercept is x is 0, y is 2. So equals to 2 and the other side of the equal sign. So then f of 0, it's going to make 0, 0 plus c on top. So 0 plus 0 plus c on top. And then 0 going in here to 2. 0 going in there, it's negative 5. But they are supposed to multiply each other. So it's going to be 2 times negative 5 on the bottom. And then it was supposed to make 2 as output. So it's 2. So then c over 2 times negative 5, negative 10 is 2. Then it was over 1, so that I can apply the cross multiply. C times 1 is C. Equal sign, negative 10 times 2 is negative 20. Then now the C turned out to be negative 20. Then let's rewrite it. X squared plus bx minus 20 over x plus 2, x minus 5. So then now we have to figure out the B. Then either one we can plug in. So let's go with 4, 0. So then now if I substitute 4 into f of x, then all x's becomes 4. So then 4 squared, 16. This is not 6, it's a b. B times 4 is 4b minus 20 over 4 plus 2, 6 times 4 minus 5, negative 1 equals to what? 0. So now I make it equal to, oh, why am I? 0. Okay. Then this is 16, take away 20. It's negative 4. Then negative 4 plus 4b over 6 times negative 1 is negative 6 is 0. Then it's over 1 cross multiply. Negative 4 plus 4b. Oh my god, this pencil is not working. Is negative 6 times 0, which makes 0. Then add 4, 4b is 4, divide both sides by 4, b becomes 1. Then we're done. I figured all the unknown there, so it was supposed to be 1 again. Then it was x squared plus 1x is just x, minus 20 over x plus 2, x minus 5, and this is totally fine to be final answer here. F of x function equation, in order to have this graph, this is it. Question. Going once, going twice. You should get 100% in the next weekly quiz. Okay, then let's go with number 3. So now, we already saw this before because we mentioned the whole here. But first, question that comes to your mind. Wait, this is just straight line with slant feature there. Why this one is supposed to be rational function? It could be just a linear function. But we found out there is a hole here. So that's what makes the difference between the simple linear function. There is a hole. Then that being said, there must be cancellation of common factor top and bottom of the fractional function format. Then that's what it makes not just simple linear function. It must have been the rational function. So now let's study about this hole. Where is this hole? 1, 2, 3, 4. 1, 2, 3 up. So the coordinate where this hole located at is 4, 3. So then, what do we do from original equation to find the position of the hole? We set the common factor that you happen to cancel top and bottom with 0. Then you solve it for the x and you get the x coordinates of the ordered pair where the hole is actually positioned. So then that could be the real important clue for us to apply backwards. So then, hole on this straight line is at 4, 3. So at 4, 3. Then x coordinate of the ordered pair is 4. So then, the common factor that we are supposed to have earlier in somewhere in the equation should have the factor with parenthesis x. This is positive 4. Then now I have x minus 4 inside of the parenthesis as the factor. But this is from whole. So then I was supposed to have exactly same factor on top as well, so that you must have canceled them in order to serve the whole later. So then at least I can start from here. I don't know what's gonna happen later, but I do know for sure I needed the same factor, x minus 4 from top and from the bottom at the same time. So then that's the really valuable information that I can guess, that I can expect from the whole. Okay, then here. Do I have any asymptote, vertical asymptote? I do not. So then I would not have an additional factor that serves the vertical asymptote for this case. So it's no vertical asymptote. I do not have to add any further factor on the denominator side. Okay, then do I have a horizontal asymptote? No, I don't have any horizontal asymptote. But do I have slant asymptote? Technically, I don't see any asymptote here, but the resultant of the graph works kind of as the slant asymptote. So in this case, we just consider this actual graph itself is unofficial slant asymptote, which follows y equals mx plus b form. Earlier, let's go back to the steps that we saw earlier. Slant asymptote is caused by actual long division that you get to divide the top 1 degree higher top by the denominator, and the result on quotient is always mx plus b form, so that you can set it up equal to y, so that you will have the linear function that indicates a slant straight line. So then, now we need to know what this unofficial slant asymptote for this case, so that we can go further. So what was the method for us to write the linear equation from the linear straight line? We get y-intercept. So y-intercept in this case is -5. Then we can navigate this slope. So now 1 unit to the right, and then it goes up 2 units. 1 unit to the right, go up 2 units, and so on. So that must be the slope. So it's rise 2 over run 1. It's a 2 over 1 serves that slope as just 2. So then now I can tell the unofficial slant asymptote is 2x plus, oh, it's not plus because y-intercept was supposed to be -5. So it's -5 here. Okay, then let's finish filling this table first. Do I have any x-intercept? Right there. It's between 2 and 3 in the middle. Then it's actually on the straight line. If I assume this one is 2.5 because it's in the middle, then it makes sense because if I just plug this back in here, 2y's of 2.5 is 5. 5 minus 5 was supposed to have y value 0, and then it must be true. Then y-intercept, we already saw there, it was -5. So it's 0, -5. It's a y-intercept. When x is 0, y is -5. So then, go back to the structure that we already came up with. Factor x minus 4 on top and bottom here. Then we already concluded I don't need any further factor on the bottom. So I will just keep this one on the bottom. Then now, I have degree of 1 on the bottom. And so far, degree of 1 on the top. But again, slant asymptote only happens when it's top heavy. How heavier on top? 1 degree larger. So if I have degree of 1 on the bottom, I'm supposed to have degree of what? 2 on the top, so that I can have long division performed, so that I have 2x minus 5 as the quotient. So then, I only have one factor of x minus 4 here. Then in order to have the highest degree on top to be 2, I need to have another factor, x, so that x times x will make x squared eventually on top. But I don't know what value that I could have here, so I'm just going to make it plus a for now. Then also, I remember the quotient when I divide the top by the bottom, the quotient goes 2x minus 5. So then in front of x, I have 2. Then I'm dividing the top by the bottom. I have to have something 2x and so on. Then I need to have 2 on top so that I could have the quotient as conclusion later too. Does that make sense to you guys? It's not going to be just 1 because I do have quotient 2. And then the dividend on top should have 2. So that when you divide the top by the bottom, then it has something 2 in front. So it's not going to be just 1 over 1. It's a 2 over 1 ratio. Okay? So if you understand that part, and then I'm just going to move on. Okay? Then we can utilize the coordinates. Yes?
Because the slope is 2?
Yeah. So if this one was 5, and then I will put 5 there. If this one was negative, yeah, probably I will have negative there. Yes. Okay. So then I can utilize this coordinates additionally. I can figure out the values that I put as unknown here. So then let's go with the y-intercept first, as we always did before. So f of 0, then now it will make 2 is 2. This 0 only affects x's, right? So 2 is 2, 2 times x becomes 0. 0 minus 4 is negative 4 times another one. This x becomes 0, and then 0 plus a is just a. And denominator is 0 minus 4 is minus 4 on the bottom. And then it was supposed to be equal to y value what? Negative 5. So then it could be 2 times negative 4, negative 8 times a over negative 4 is equal to negative 5. Then you can do it too. But I noticed this negative 4 top and bottom as a separate factor. Why don't I just cancel already so that my life easier, make my life easier. So then it's 2a over 1 is negative 5. All I have to do is divide both sides by 2. Then a is negative 5 over 2. Yeah, I will just keep as fractional form. Or if you want to, you can just go ahead and make it as negative 2.5. Totally fine. So then I know this a is supposed to be what? Either negative 5 over 2 or negative 2.5. Then I can rewrite it to be the final answer. So the final answer is going to be f of x 2 times x minus 4, and x a is supposed to be what? Negative 2.5 over x minus 4. This is totally fine for me. But if you kind of get bothered by unconventional value that you see, and it's totally fine that you notice 2 is in front of it, and then you can distribute it into this second parenthesis. This is totally fine too. So the first parenthesis as is, but 2 times x will make 2x minus 2 times of 2.5 was 5. Then over x minus 4 is the same. Then it's a little bit less bothering for the conventional mathematician. But this is totally fine too. Just give you an idea. Good. Any question?
How did you get the first x minus 4s?
Oh, because we had whole, the discontinuity, where it was at 4, 3. Then you have to remember how we get the discontinuity. We're supposed to find the same factor top and bottom to cancel so that we can serve that fact as whole. Then you focus on the x coordinate of the ordered pair where you can find the whole. It was 4. So then that being said, we're supposed to have same factor top and bottom to cancel in order to find the x coordinate 4. So then the original factor appear the same top and bottom has to be parenthesis x minus 4 on the bottom, parenthesis x minus 4 on the top. That's the starting point that we started to have there. Yeah?
How did you get the 2 again?
Oh, 2. Okay, then earlier we were discussing either we have horizontal asymptote or slant asymptote. And then we decided to consider this actual slant line, unofficially our slant asymptote here, right? Then the way that we find slant asymptote is we divide the top, 1 degree higher top, by the denominator so that the quotient will look like mx plus b form. So then what we have here down here, it's a 2x minus 5. So then if you have the quotient 2x, that being said, the top, 1 degree higher top being divided by the bottom, and then you're supposed to have twice of the top. So then I have to put the leading coefficient on top as 2. So it's like if this one was something else, and then we can just have this. So then it's gonna be 2x squared plus something, and plus something, and so on. And then we're dividing this one by what? x minus 4, right? Then, in this case, what you have on top will be this, 2x, so that you can multiply 2x times x being 2x squared down here. And then it was supposed to be negative 4 times 2x, it's negative 8x. Then what you were doing was always like minus here, plus there, because you are subtracting and then you cancel and then you move on. You remember, this is how you can do long division over polynomial. So then, unless this one had 2 on top, you would not be able to have the quotient here as 2x. So then if you understand that one and you apply that fact backwards, and I know for sure the top has to have twice bigger coefficient than the denominators. So if this one turned out to be 5x plus 1 or something like that, we don't really care about the other term afterwards, but we are focusing on if this is 5x, and then probably I need to put 5. So that when you perform the long division, it was supposed to have like a 5x here. Does it make sense? Yeah.
Wait, this part.
Yes.
You also just like it rises 5 and goes over 2.5, and 5 divided by 2.5 is 2.
The x-intercept?
No, for finding the slope.
Finding the slope. Okay, so then you can go from anywhere in this slant line and then you navigate
5
to...
and then over 2.5.
Oh yeah, that too. So then it's gonna be
That's
like...
a lot easier way to do it, right?
Yeah, it depends person by person, I think. For personal...
That explanation made me more confused,
What? Yeah. So either way, you can just consider this one is just like you go to 5 units to the right, but it just like makes you to go 10 units up. So then you will still have the same conclusion with this slope too. So no matter how many units that you investigate to come up with the slope, it's always gonna be 2 for this one. Yeah? Yeah, it doesn't matter. Yeah. So its constant ratio is 2 over 1. And then it makes the slope 2. Cool? Cool. Okay. Okay. So then let's move on to number 4. So number 4 will be a little bit more like comprehensive that we get everything so far. Look, now I do have official slant asymptote. And then I do have what? Actually, there's a vertical asymptote. Then, at least I don't have any open circle around my curve. Then probably I will be free from dealing with holes here. But again, I do have official slant asymptote. I do have official vertical asymptote. Since I do have slant asymptote, of course I don't have horizontal asymptote. But I do have x-intercept and y-intercept. So, but I don't have holes, no holes. Vertical asymptote where? It's 2 units to the left, so where x is -2. But I only have one vertical asymptote. I don't have any horizontal asymptote, but I do have official slant asymptote. So then, let's figure out the linear equation of the slant straight line here. First, yes?
It'd be x minus 2.
X minus 2? Yeah, exactly. So then, y-intercept is -2. So then that's y-intercept, b. And the way that I would figure out the slope is 1 unit to the right, 1 unit up, 1 unit to the right, 1 unit up. Or you can just go 2 units to the right, 2 unit up, or 3 3 units to the right, and yeah, and so on. So it will always give you the same ratio. It's same top and bottom, which is 1, and then it's gonna be just x, right? So then I can write y equals x minus 2 being my official slant asymptote. Yeah. Then where do I have x-intercept? Here and there. So it's -1, 0, and 1, 0. Very good. And where do I have my y-intercept? It's between 0 and -1 in the middle. And for a quiz problem, if this is in the middle, and then I will just give you accurate coordinate there. But let's skip this. This one is just 0 and -0.5 for sure. Okay, I will be more clear when I give you guys the quiz problem, but let's say this is just 1/2, -1/2. Okay, then let's construct our equation now. I don't have any hole, so I would not be able to start by putting the common factor top and bottom at the same time. So that's not the case. But I can start from the fact I do have official vertical asymptote at -2. So at least I have something on the denominators. There is one factor, parenthesis. And then it's gonna be what inside? It's -2. So what? X plus 2 on the bottom. Okay, then now the fact that I have slant asymptote, so then compared to the degree of the denominator 1, I have to have what degree on the numerator? 1 larger than the degree of denominator. So I am supposed to have degree of 2 on top. Then I know for sure the top has to have quadratic expression because the highest degree is 2. It's a quadratic. So then now I can have ax squared plus bx plus c form there. Then now I have to determine the leading coefficient of the numerator. Then I will look at the quotient that I'm supposed to have when I perform the long division, the dividing the top by denominator. Then this is leading coefficient A, but then now I don't have any specific number, it's just invisible 1 there. So then I don't have to have a specific number as a leading coefficient, it's gonna be just 1. So imagine that you're dividing x squared plus bx plus c by x plus 2. Then only to match this x squared, all you need is x on top. So x times x is x squared. 2 times x is plus 2x. Then you change the sign by subtracting it. Then cancel, and then you can move on. So then if the quotient is x plus something later, and then it has to have 1. So then now it forces us to have the leading coefficient only just 1 right there. But we're still responsible to find B and C. But we already did several times before, and it's not going to be complicated. All we have to do is properly input coordinates from here. So then let's do y-intercept coordinate substitution first. So then with this format, f of 0, it's gonna be 0 squared, 0, 0 times b, 0, plus c over 0 plus 2 is 2. It's supposed to be what? Minus 0.5. It's -1/2. Then next step, 0 plus 0 plus c is c. So c over 2 is -1/2. Then what's c? C is -1. Okay, C is -1. Then it was supposed to be x squared plus bx minus 1 over x plus 2. So then now we're still responsible for unknown b. Then which one would you pick to substitute? -1, 0, 1, 0, it doesn't matter. But if I pick -1, and strategically it will make the denominator 1, and then I will just go for it. So then let's plug -1 comma 0. So then if I plug f of -1, then it's gonna be what? -1 squared is 1. -1 times b is -b. Then I copy -1 there. Over x becomes -1. -1 plus 2 is 1. And then it's supposed to be equal to what? 0. So it's a 0 the other side. Then what's 1 minus 1? It's a 0. So it's supposed to be -b over 1 is -b. And then it's supposed to be equal to what? 0. If -b is 0, b is 0. Then if b is 0, I don't even have this midterm. So then what's the conclusion? The original equation must be x squared, but I don't have midterm. But the last term is what? -1. And then what was the denominator? X plus 2. That's it. This is final answer. Or you can just factor this. Notice this one is difference of squares. So it could be x plus 1, x minus 1, over x plus 2. This is good too. But you can leave it like either way. Done. Look, this weird shape of graph was from this weird shape of equation. Everything is weird. I'm done. Any question? Are we getting the better understanding how to write equations from the given graph? And then you should be, no? Yeah? Yeah. Yeah. Then either you get actual graph or written explanation of the description of the graph. In either way, you should be able to go backwards to create the equation. So, to be fair, I will edit any of the lecture video out of all 4 classes. I will pick the best one and then I will upload it on Sunday night. And then I will also make videos separately to go over number 5 and 6 and 7. And then I will also upload that video. And then I will also upload the notes of this because I only gave you guys the blank one only. Then I will also upload the notes for every single page there so that you guys can follow through the videos. Then I will add 1 or 2 more additional practice with answer keys. Then I will make quiz, exactly same 9 points quiz, but I will try my best to make all the problems there very similar to these 7 examples. So you should be able to do it. Whether it's given with the direct graph or the description, written description of the graph. So either way, and then you should be able to find the right equation, and I will still make it multiple choice, and then it should be better. So then hopefully you get recovered from this week's weekly quiz covered by next week. Then I just realized next week is 2 weeks before the end of May. So next week you will have another 9 points quiz. And the last week probably I will give you the whole comprehensive mastery check. So it could be a little bit longer and then it could take more points. Then you can take that and all the results will be gathered together to be data for me to just come up with the matrix to convert to your 10-week grade, how high that could go from your 10-week grade to determine the final course grade. And then that's all. Then you're free from me. That's all, right? How cool is that? Oh, let me stop this. Okay. If you guys don't have a specific question from this one, and then I will just stop share. Cool? Okay, stop share. Okay. How was now? A little bit better? I hope it's better. Cool? Okay, how are you guys doing on your AP exams? Good?
I had my AP Euro exam 2 days ago.
Oh, how was it?
I slapped myself in the face to stay focused.
But how do you guys even take the AP exam online?